We're going to look at two examples. The first one is going to be using these two functions, actually just a single function, but I did have a typo in number 5 on the worksheet. So number 5 on the worksheet should have been functions the same, cosine x, sine x, and we're still using the same interval, 0 to pi halves, but the axis of revolution should have been y equals 0 instead of y equals pi. I have graphed this, so let me go ahead and grab my graph, which is right here. So on the graph, let's go ahead and take a look at it. So I'm going to graph it. And I see that it looks like these little bumps here. If I hit trace, I can see where 0, 0 is, but let's go ahead and put in pi halves. And we see it's just at the end of that first curve. So I'm going to change my viewing window so that I can see just that much. So how about -1 on the x-axis? We just want to catch that first period of it. Pi halves, let's just have this go to 3, which would be less than pi halves. And then my scale, I'm going to let that be 1. You can leave it there if you want. Everything was positive, so I'm going to make that a -1. And then a y max of 4 would probably be just fine. So I'm going to go ahead and graph it. I want to get a good looking graph here so that I can draw it, there it is, and come up with what that revolved volume is going to look like. So let me transfer this over to my paper here. So it looks like this. This is 0 for x. This is pi halves for x. We're going to revolve it around y equals 0, which is the x-axis. As I'm revolving it around the x-axis, I can see what shape my disks are going to take. I start by drawing that reflection across the x-axis, and I've done that. And then to give it a little bit of a dimension, I'll go ahead and draw this. Let me put in a disk. So a disk, if I do this one here, is going to look like this, and that thickness, which is here, is in the x direction, so that would be dx. So I pull this off. It's going to get messy here. I also need to figure out the radius. Well, the radius goes from the x-axis up to my curve. There is no inner volume. Nothing's been taken out of the middle. It's completely solid. So I just need a single radius. That radius goes up to my curve, and my curve is defined by my function y. So the radius is the square root of cosine x sine x. I'm ready now to put this into my volume of a revolution formula. So volume is the integral of this function from 0 to pi halves, and then pi r squared to get the area of the circle, so pi r squared, and then dx is the thickness for these disks. So volume is, I can pull the pi out, 0 to pi halves. I'm going to square r, which leaves me with just the cosine and sine left. So I'm going to go ahead and write that, cosine of x, sine of x, dx. This one's a really nice u substitution. So if I let sine be u, then cosine is du. So I'm going to go ahead and do my u substitution. Let u equal, I said sine. That means that du is cosine, and I'll tack that dx on the end. So I've got everything. I don't need anything else for du. Then I've got to change my limits of integration as well. When I put 0 into u, so u sub 1 is going to be the sine of 0, which is 0. And then u2 is the sine of pi halves, straight up. The sine of pi halves is equal to 1. Changing my integral using my u substitution, my volume in terms of u. The pi is a constant, so it can stay out front. 0 to 1. Sine is u. Cosine and dx together are du. super nice integral. I'm just going to use the power rule here. So pi, for that power rule, I get a 1/2 u squared, evaluated from 0 to 1. Pi gives me, let's see, 1/2 times 1 minus 1/2 times 0. So my volume is pi halves. Okay, so there's the last example with that axis of revolution corrected on the worksheet. I have another example that I want to work with you as well, and I've graphed it on the calculator. So let me go ahead and bring the calculator up. Y equals, I want to not graph this first one, so I'm going to highlight the equal sign or unhighlight it. Let's go ahead and highlight the other two. I'm going to highlight y2 and highlight y3, and then make sure I get y1 so it's no longer highlighted. Okay, so there we go. I'm going to go ahead and graph this, but I want to do a zoom standard first, because I messed that zoom up. And you can see I get this little shape there. Let me draw that on my screen. So let me give ourselves a new page. For this one, you saw the two, but let me write the two functions for you. So for this example, I wanted to do one around a different axis. So I have y is equal to 2 radical x, and y is equal to x. And we're going to revolve this about the y equals 4 axis. When I draw this, I came up with that square root function and my line y equals x. So this is y equals x, that's my square root function. And I end up with this area in between here. This actually gets us to a couple of really good examples. I'm doing an area between two curves, and I am revolving it about a different axis. The first thing I want to do, since I'm looking at that area between two curves, is to figure out what my points of intersection are. I can see the first point. The first point is at 0. To find the second point, really, and the first point, I'm going to set my two functions equal to each other. So 2 radical x equals x. I'll square both sides. 2 squared x is equal to x squared. Getting everything on one side, then I get 0 equals x squared minus 2x. Factor the x out. X minus, oh, that should be a 4, right? 2 squared, this is a 4. So I get x squared minus 4, not x, or sorry, x minus 4, not x minus 2. Okay, x and x minus 2, 4. So now I get my two values. I can keep those straight. So x is equal to a 0. We had that one. And x is equal to 4 now that I fixed my 2 squared. So that tells me that I'm going to be here when x is equal to 4, y is equal to x. So that means y is also equal to 4. So I'm going to go ahead and mark that because that happens to be where my axis of revolution is. I need just a little more room, so let me draw this so I am in just the first quadrant. There's my area. I want to revolve it around the axis here. And when I revolve it around the axis, I'm going to go ahead and draw that mirror image. And then my revolutions is going to give me this kind of a shape. So I've got this inside that is thick, but I also have this inner piece in the middle. So it's kind of like a bowl. It comes to a point at the end. It's a bowl, but it has this curved shape on the inside. What I need to do is to figure out, well, I've got my discs already, right? So I know that my discs are going to be up and down. So as I'm looking at these individual discs, they are in this direction, the same direction that we did the revolution. So I do want a dx, that's how my thickness is. But as I take one of these discs, I have an empty piece in the middle, so I actually have a washer instead. My inner radius goes from the axis of revolution. Let me see if I can erase some of this. It's going to go from the axis of revolution, and if I just draw the cross section, be able to see that. There's that one, and then this one here. There, how about? Just draw that in and draw that in so we can make it look a little bit nicer. And then let me draw my axis of revolution in, because this part's really important. And then I'll erase whatever else I've got. Okay, so just cleaning this guy up a little bit. Get rid of this as well. So as I clean this up, I have this. I am looking at one of my circles, and what I really need to do, one of my discs or washers, what I really need to do here is to figure out, let me draw this, what my inner radius is and what my outer radius is. Well, to get to an inner radius, I have to go up to my axis of revolution, which is 4. That inner radius, I need to go from 4, but down to this curve, and the curve is y equals 2 radical x. So our inner, to get to the points on the inner radius, I need to go up to 4, my axis of revolution, whoops, and then down to the inner layer. So the inner radius is going to be 4 minus 2 radical, this should be radical x, so 2 radical x. And then my outer one, if I do this in very much the same way, I need to start with my inner, I'll do a blue one, so I need to start with my axis of revolution first. So I start up here at 4, but now I need to go all the way down to the straight line, to that diagonal y equals x. So my outer radius goes from the center here down to my straight line. So I can say that my outer radius is given by 4 minus x is my line. So 4 minus x. So you can double check yourself here. When x is equal to 0, I should be at a radius of 4. And when x is equal to 0, I do have that outer radius of 4. So I know that I'm working this right. And, oops, inner radius is 4. And when I'm at x equal 4, I should have an outer and inner radius of 0. So my outer radius is 4 minus 4, which is 0. So I can go ahead and do kind of a quick double check that way. Let me clean everything up here and put it all into an integral using my black pen here. So the volume is pi. I need to do the outer radius squared minus the inner radius squared, or you can do this as 2 separate. So I'm going to do the outer radius squared minus the inner radius squared dx, because my thickness is in the x direction. I've got everything else now. So I have pi. Oh, I need my my 2 limits of integration, and they're right over here. I did forget to write those down, but now that I'm putting everything in here, I need them. So I'm going to go from 0 to 4, and that came from finding the points of intersection. So 0 to 4. My outer radius is 4 minus x. So 4 minus x squared minus the inner radius, which is 4 minus that curved function 2 radical x squared dx. I'm done with the tough part. So I thought through all of that. I came up with my outer radius and my inner radius, making sure to catch any little errors that I might make along the way. Here's my axis of revolution, and I had to go down to find the radius for both the outer and the inner. So now I just need to do some algebra. So I've already done some of this. When you multiply and combine like terms, you get x squared minus 12x plus 16 radical x dx. When you integrate and evaluate from 0 to 4, you're going to end up with a volume of 32 pi thirds.